start with our math lesson today. This is Saxon Algebra 2, lesson 14. We're also going to cover, as you can see up here, 15 as well. Both lessons 14 and 15 are really short lessons. We're going to combine those two in this one video in one lesson. Lesson 14 is finding the equation of a line. Now we know most of this already, which is kind of why we're combining it already. It should be an easy grasp for us. There's just a couple things that we need to know, need to remember about lines. That starts with the equation of a line, the basic equation of a line. Y equals mx plus b. Now remember, y and x are simply our unknowns. M is our slope, and remember the slope is the rise over the run, and this could be positive going up or it could be negative going down, and B is simply our y-intercept. So what we're going to do now is try to find the equation of a line when we're given not just the line or not just a drawing, but given some points, as we can see in example 14.1. They give us two ordered pairs, and each ordered pair, in this case -3 and 2 and 3 and -3, are simply two points on this plane. So what we'll do, and you don't necessarily have to have a graph paper to solve these. It may help you, but you don't have to have that. What we're going to do is just take a real quick look at the plane, plot it real quick, and then we can show you what we're doing from there. So we'll plot this one, we'll label it A, and it's -3 and 2. So this is the x-axis, this is the y-axis, x, y. -3x, so -1, -2, -3, and then 1, 2 on the y. That's our first point. Our second point is 3, -3. So we're going 3 on the x, 1, 2, 3, and then -3 on the y, 1, 2, 3. So we have this line that looks like that. Now, to find out, or to find the equation of that is not really difficult. What we're going to do is this. We're going to have to find first the slope. Now, there could be, from this point to this point, there could be a place where it crosses a corner exactly, and the slope could be less than what we get here. Well, in this case, it won't be, but in some cases it may be. But you don't have to worry about that. You can take any 2 points and get the rise over the run, even if it's a reducible fraction. You can still take that rise over the run and get the right answer. Now, if you see it's a reducible fraction, you may just go ahead and reduce it down to its lowest terms. That'll make it easier on calculations. All right, so we'll see what we've got here. So what we need to do is come here, get this right triangle going here, and see how far it is from here to here. Now remember, we went up 2 and went down 3. So 2 plus 3, although that's a negative, it's going to have this 2 and this 3 here. So 2 plus 3 gives us a total of 5. So we're going down 5 to get to this plane, and then we're going over. We started at -3, and we're going over to +3. So this is 3 and this is 3. So those two combined is 6. So our slope is -5/6. Okay, so we have our equation. Y equals -5/6x plus b. Now that may look good, but we're not finished yet. We don't know what b is. You remember what b is? Actually, it's the y-intercept, where it crosses the y-axis at. Now you may be able to look at it and say, okay, I think it crosses right around here. But as you learn in math, you can't, and especially geometry and maybe these planes here, you can't rely upon your eye. You have to figure things out, or you have to be able to prove it. And so we're going to prove that right now. So how do we find b? Well, simply what we're going to do is we're going to take one of these, either it's -3, I didn't label those like I should have, either -3 and 2 or 3 and -3. We'll go ahead and take the first one, A, -3 and 2. We're just going to plug it into this equation, okay? So remember, this is x and y. Ordered pairs always go alphabetically. So y is going to be 2 equals -5/6 times -3 plus b. All right, so we're going to do some figuring here at this point. Well, we have 2 now equals, well, we know 3 and 6. We can do a little bit of figuring there. When we're multiplying, by the way, if we're multiplying a fraction by a whole number, we put that whole number over 1. And so we can do some canceling. 3 goes into 3 one time, 3 goes into 6 2 times. And so we actually have a positive 5 over 2 plus b. So 2 equals 5 over 2 plus b. So are we done yet? Well, no, we're not done. We're not done yet. Why not? Well, because we got to get b on one side by itself, because that's what we're trying to solve for. So I'm just going to flip the equation. B is going to equal 2 what? Well, 2 minus 5 over 2. Well, how do we know minus 5 over 2? On this equation here, if we wanted to get b by itself, we'd have to get rid of that 5 over 2. It's being added to b, and so we're going to take it over here, change sides, change signs. Right, so it becomes a negative 5 over 2. So I just flipped the equation so it'll make more sense right here. So what's 2 minus 5 over 2? Well, we have to get common denominators. And so that's going to be 4 over 2 minus 5 over 2, which is going to give us a negative 1 over 2. And so the negative 1 over 2 is our b. So now our equation is going to read y equals negative 5 over 6x minus 1 over 2. And this is the equation that they're looking for. That's what we get. Now, I know it seems like a lot of work, but all we had to do first was find our slope, which we did here, rise over run from one point to the next point. And then from there, we just picked one of the ordered pairs. In this case, we used negative 3 and 2 and plugged it into our equation. The y equals negative 5 over 6x plus b. And then we solved for b. And then once we got b, we took that and plugged it right back in to that equation, and it gave us what we were looking for. Okay, so let's look at 14.2. Now 14.2 is a little different. Matter of fact, it's a little easier. They take some of that guesswork out for us because they only give us one ordered pair, and they give us the slope. You can read that in 14.2. Find the equation of the line that passes through this point. It has a slope of negative 3 over 5. So we don't have to go through the hassle, if you want to call it that, of finding the slope. They already give it to us. So remember, y equals mx plus b. In this case, y equals negative 3 over 5x plus b. And then we only have one point to work with, so that's the one we're going to have to plug in. So in this case, 7 equals negative 3 over 5 times negative 4 plus b. All right, so remember, we're solving for b again. So let's go ahead and do our multiplication here. 7 equals 12 over 5 plus b. Remember, a negative times a negative is going to equal a positive. Again, we get b by itself, so this 12 over 5 comes over here, change sides, change signs. I'm going to go ahead and flip that equation. So b equals 7 minus 12 over 5. I need to make this a fraction. I need to get common denominators in order to subtract. And so that is going to equal 35 over 5 minus 12 over 5. Get a little sloppy the lower I get, and I apologize for that. But what do we have here? So b is going to equal what? 35 over 5 minus 12 over 5. What's that going to give us? Well, it's going to give us 23 over 5. So b is 23 over 5. Now, do I leave it in 23 over 5, or do I make it not just an improper fraction, but a mixed number? Well, I'd say we leave it like this. You could write it either way, but it's not going to hurt at all to leave it like this. So what we need to do is take this 23 over 5, plug it into our equation right here. So we have the y equals the slope that we were given, negative 3 over 5x, plus 23 over 5, the b that we solved for. And that should be pretty simple to see. We're doing the same process that we did in 14.1. It's just that they gave us the slope to work with. And so hopefully that'll be easy for us to follow. Okay, we're going to flip on over to lesson 15 and see what's going on there. It's elimination. We just talked about substitution. So we're doing basically the same type of problem, the system of equations, as we did with the substitution, except for now we're going to find a different method to solve them, and that is the elimination. There are even more methods to solve that. Maybe when you get past high school and get into college, you'll get into some college algebra and go on farther and maybe take some linear algebra. And when you deal with linear algebra, you'll get to see some system of equations with not just 2, but sometimes 3, 4, 5, 6, 7, even some that we've solved up to 13 different equations. And it can get kind of hairy that way, but that's why there's multiple different ways to solve these. But the two we're focusing on here are substitution and elimination, and they each have their place. You can do either one for any and every system of equation that you come across in this book. It's just that sometimes one is a little easier to solve than the other. So let's go ahead and look at this. We're going to save this one just a second. We're going to come down and look at this. This is an example that's given in the book before our example 15.1. And so we look at it and we see 2x plus y equals 11. And 3x minus 2y equals 6. Now, before we use substitution, we found one of these equations and made it y equals, and maybe in this case, we would say y equals 11 minus 2x by taking this 2 over x over here, change sides, and making a negative 2x. Let's kind of do that here. If I took this over here, made it a negative 2x, we could take this whole thing and plug it in for y. That would be substitution. That's what we've already learned. That's not a problem. It's just not what we're learning today. There's a different method that we're going to learn today. And elimination is simply what the name sounds like. We're going to eliminate either the x's or the y's. Okay? And you say, well, okay, which one do we do when we come to our problems? Well, it's up to you whether you want to eliminate the x's or eliminate the y's. Now, there's a couple things you're going to look for to decide which one I'm going to eliminate. And so we always look at the x's and we see, is there the same number with the x's? Well, no, that's a 2 and that's a 3. Okay, so that's kind of a strike against it. I'm looking for either the x's or the y's to have the same number. Look at the y's. This is a positive 1 and a negative 2. So no, neither one of them have the same number. And so once I find out if neither one of them have the same number, then I'm going to look and see if either one of them have opposite signs. And say, well, why does that make a difference? Well, because we need, in order to eliminate, we need the x's to have opposite signs, or we need the y's to have opposite signs. So let's look here at the x's. This is a positive 2x, positive 3x. They have opposite signs? No, they don't. They're both positive. Look at the y's. Positive y, negative 2y. Have opposite signs? Yeah, they do. Okay, so then we decided now that we are going to eliminate the y's. That's what we're going to do. So how do we do that now? Well, in order to eliminate the y's, not only do they need opposite signs, but they do need to have the same coefficient. They need to have the same number in front of it. And you say, well, that's easy. We'll just write in a 2 right here. Well, you can't do that. And so what we have to do, because it's an equation, we're going to have to multiply this y by 2. But if we multiply this y by 2, we have to multiply everything by 2. So we have to multiply this by 2, this by 2, and this by 2. So what happens is we get the equation 4x, because 2 times 2x is 4x, plus 2y, because 2 times y is 2y, equals 22. And we'll go ahead and rewrite this one. 3x minus 2y equals 6. You see, and now what happens with this equation is I have a y that's the same number, but opposite signs. So I can just add straight down. 2y minus 2y. Boy, that's 0. That's nothing. 4x plus 3x is 7x. I'm going to go ahead and take that 0 out of there so we don't get confused. But we understand that those cancel. Equals 28. Now 7x equals 28. How do we solve for x? Well, divide by 7 on both sides. 7's cancel here. X equals 4. All right. Now if x equals 4, what do I do at this point? I know my x is 4. Well, I'm just going to plug it back into this equation. 2 times 4 instead of 2 times x because x equals 4, plus y equals 11. 8 plus y equals 11. I'm going to take this 8 over, change sides, change signs. 11 minus 8, y equals 3. So I just plug it in up there. My ordered pair is 4 and 3. So it's a simple process once you've done it a few times. I know right now you think, boy, that's a lot to remember. Really only 2 basic things you got to remember. Whichever x or y you're wanting to eliminate has to have the same number and opposite signs. So let's go ahead and look at the example that they give us in the book. The example that they give us, excuse me, in our book on page 80 is 3x plus 2y equals 23 and negative 2x plus 3y equals 2. Kind of an interesting thing here that they give us. They give a 3x and a 2x, a 2y, and a 3y. And the reason that's interesting is because we need the numbers to be the same. And remember, so this is what we're first looking for. Are either numbers the same? No, they're not. Then I look, which one am I going to eliminate? Which one has opposite signs? Well, which one is that? The x's. So we're going to eliminate the x's. Now here's the problem. We need the x's to have the same coefficient, the same number. So can I multiply this top line by anything to make it match this x to be a 2? No, I sure can't. I can't multiply 3 by anything to make it 2. Can I multiply 2 by anything to make it a 3? No, I sure can't. And so what I have to do is multiply both numbers in order to get the number that I'm looking for. I'm looking for the least common multiple of 3 and 2. And what is that? The least common multiple is 6. All right, so how do I get to 6 from 3? Well, I got to multiply it by 2. So that means this has to be multiplied by 2, and this has to be multiplied by 2. Then I go down here. How do I get that 2 to a 6? Well, multiply by 3, this by 3, and this by 3. So what I end up with, I'm going to rewrite both equations now. I get 6x, because it's 3 times 2x, plus 4y equals 46. All of these were just multiplied by 2 to get my answers here. Then on the next equation is minus 6x plus 9y equals 6. Okay, you see what happens already. I have a positive 6x here and negative 6x here. So what happens? The x's are eliminated. I'll add straight down. I have a 13y equals 52. Okay, so what do I do to solve for y? Well, I'm just going to divide by 13 on both sides. And you may not be able to see it right now. The more math you do, you will. 13 goes into 52 4 times. And so our y is 4. So where do we go from there? Well, we have to plug that y back into one of our equations. And so I'll just use the top equation again. 3x plus 2 times 4 equals 23. 3x plus 8 equals 23. Again, x is by itself. I'm going to take this 8 over here, change sides, change signs. So now I have 3x equals 15. Divide by 3 on both sides to get x by itself. X equals 5. And so my ordered pair is 5 and 4. I hope that explains that well. And if you have any problems, get in your book, follow along in your book, write through one of these examples again, and that should help you. If you have any questions, as always, let me know. We're glad to help you out with them.